Okay, so during today's lecture, we want to start a discussion of something called scalars and vectors. Scalars and vectors is another way of grouping these physical quantities which I've looked at in the other chapter where we're discussing base quantities and derived quantities. So what is a scalar and what is a vector in physics? Okay. So a scalar is a physical quantity which only has magnitude or size. So those physical quantities which only have size, those are what we refer to as scalars. While a vector is a physical quantity which has got size and direction. A good example of a scalar is mass. We just say this object weighs 10 kg or this object weighs 5 kg. Okay? In that, for mass, there is no information about direction because mass does not have direction. On the other hand, something related to mass, which is called weight, weight has got direction because the weight of any object always points down towards the center of the earth. Okay. And weight is measured in newtons because weight is a type of force. So in the case of mass, mass is a scalar. Weight, which is a force, is a vector because it has got size and it has got direction. For us to find the weight, you have to multiply the mass by something called acceleration due to gravity, G. So any physical quantity which only has got size, we classify that as a scalar, and the other physical quantities which have got size and direction, those we classify as vectors. Another example, as we're going to see, is distance. If you tell someone you ran a distance or you walked a distance of 100 meters, that information you're presenting as a distance of 100 meters just tells us what's the size of the length or the distance you covered. It does not say anything about in which direction this distance was covered. But on the other hand, if you say you ran a distance of 100 meters towards the east, that's different because in that case there is how much distance you covered and there is also the direction in which you cover this particular distance. So distance in a specific direction, that is what's referred to as displacement. So there is distance and there's something called displacement. Distance is a scalar. You just talk about the size which has been moved or has been covered by a particular object. Then there is displacement, which is distance in a specific direction. There is how much distance you have covered, and there is also information about the direction in which this particular distance was covered. So basically, that's in a nutshell is what scalars and vectors are. Are we clear?
What's the difference between distance and displacement?
Displacement is distance in a specific direction. So if you cover a distance of 100 meters towards the east, that is what's called displacement. A displacement of 100 meters east. Distance does not have direction. That's one thing. Are we clear? There are certain physical quantities which only have got size. Those are called scalars. There are other physical quantities which have got size and direction. Direction is important. It can't be ignored with these physical quantities when you're looking at them. Those are what are called vectors. Okay. The other thing we're going to do is we're going to see during the course of the lecture how to break down a vector into what are called components. into something called components. So basically these are, a component is how much a vector is in a particular direction. That's what a component is. So the directions we'll be concerned with during the course of our studies is two directions which are 90 degrees to each other. One of them we're going to call the x direction, like the one on your xy plane. So we're going to be using the xy plane. So one direction will be the x direction, the other one will be the y direction, and these directions will be at 90 degrees to each other. So if you have a vector which does not point along the x axis or along the y axis, but wherever it points, then you want to find out how much that vector is along the x-axis or how much that vector is along the y-axis. Then that's what's referred to as a component. Okay? Then after finding components, we are going to learn how to add and subtract vectors. We are concerned with the addition and subtraction of vectors because when it comes to scalars, adding scalars and subtracting scalars, this is something you have been doing for a long time. So you know how to add scalars. For example, how to add mass. 5 kg plus 8 kg, you know that's going to give you something like 12 kgs. If 5 plus 8, yeah, something like 12 kgs or 13 kgs. I'm not sure exactly. But you know how to add things. 5 kg plus 3, that's 8 kgs. 5 kg plus 3 kgs, get 8 kgs. So the addition of scalars is something which you guys are familiar with, so we're not going to bother ourselves very much about that. We're going to draw on your experience on how to add scalars. Okay, so what are the objectives during this lecture? So you should be able to define what a scalar quantity is and also give examples of scalar quantities. We're going to give some examples of these. Also, you should be able to define what a vector quantity is and give examples of vector quantities. You should also be able to decompose. To decompose is to break down a vector. In our case of vectors, you should be able to break down a vector, or the other word for decomposing a vector is to resolve a vector into its components. Okay. Then the last bit is you should be able to add or subtract vectors. So this is a requirement for the course. Knowing how to add and subtract vectors is a requirement. Are there any people we need to admit? Yeah. Okay, so all the quantities you have looked at, whether they are SI based quantities or that's someone's microphone which is on. Okay. All the physical quantities you have looked at, SI based quantities and SI derived quantities, we can group these into scalars and vectors. Scalars are those physical quantities which only have size or magnitude. They do not have direction. Vectors are those physical quantities which have got both size and direction. Okay. A vector, mathematically, we denote a vector in mathematics and physics like this. So you can write the name of the vector, the symbol, which denotes that particular physical quantity. Then you put an arrow on top, or you can write the symbol in boldface. You can also present a vector in form of a picture like this. So what's required if you're presenting a vector in form of a picture is one, that it needs to have a start point, it needs to have an end point, and the direction in which the vector is pointing is shown by this arrow here. Okay, so it needs to have a start point. The vector is starting at A here, then it ends at B. Then the direction in which the vector is pointing is shown by the arrow there. So when we'll be talking, whenever we are talking about a vector, you need to show the direction in which the vector is pointing. Okay, it's possible for you to draw your arrow to scale. However, that will not be necessary. So what you're actually going to be doing is two things. You show us the direction in which the vector is pointing. So you draw a line, then an arrow saying this vector is pointing this particular direction. Then here on top here, you put the size of the vector. So that way the information about what's the size of this particular vector is, we have the information. So you put the name of the vector and the size, and also the arrow shows the direction in which that particular vector is going to be pointing. So basically that's what we're going to be doing. We will not be drawing these vectors to scale. Sometimes, most times, we'll draw vector, we'll represent vectors in a picture form like this, an arrow, the arrow showing the direction in which the vector is pointing, and the size of the vector we're going to write it here. If it's a displacement, we say 5 meters. If it's force, we'll put it here, 10 newtons, like that. Are we clear? On how vectors are presented?
Yes, sir.
All right. Here, I'm trying to show how you add scalars, which are these physical quantities which do not have direction. They only have size. For example, 5 kg. 5 kg is a mass. Okay? 5 kg plus 3 kg, this gives you 8 kg. So you just add these numbers. 5 plus 3, that's how you get the 8. Then the units, the kgs remain. The units don't change when you're adding the same physical quantity. 5 kg plus 3 kg, that gives you 8 kg. 25 seconds. Remember, the kind of time we're interested in is the duration. So something lasts 25 seconds, then minus 13 seconds. From that 25 seconds, if you subtract 13 seconds, then you get 12 seconds. So this is straightforward because mass does not have direction. It's a scalar. Time is a scalar. Okay? Then you can also add distances. 25 meters plus 50 meters, you get 75 meters. In this case, we don't have to bother ourselves about the direction of these distances because it's not important. What you're dealing with is distance and not displacement. Okay? Then here, 1.5 mole plus 0.7 moles, that gives you 2.2 moles. Amount of substance, which refers to how many atoms or molecules you have in a particular substance, does not have direction. It's just how many of these things you have. So, the point here is, when you're dealing with scalars, you just do simple addition or simple subtraction. Are we clear? When you're doing addition or subtraction, when you're doing addition or subtraction of scalars, it's just simple addition or simple subtraction. Here's an example of physical quantities, which are scalars and which ones are vectors. You've got mass. Mass is a scalar. It only has size, length. It depends on the length. Okay, for example, a distance or a radius, that's a length. It's just a size. There is time, then there is electric current, temperature, amount of substance, light intensity, area, volume, density, speed, energy, work, power, frequency, charge, voltage, resistance. These are examples of scalars. As you can see in this list, it's a combination of base quantities and derived quantities. But now we are grouping them according to whether this particular physical quantity only has got size or whether it has got size and direction. These other ones, vectors, examples are displacement. Displacement is distance in a specific direction. That's what's called displacement. So you cover a particular distance, then you tell us the direction in which you covered that particular thing. Velocity is speed in a specific direction. Again, there is change of there is speed there, but you're doing this speed in a specific direction. Then there is acceleration. Acceleration is how fast the velocity is changing. So for the velocity to be changing, it's changing in a specific direction. Then there's force. You apply a force in a specific direction. There's pressure. Pressure is applied in a specific direction. Okay. Pressure. Remember, pressure is force divided by area. If force is a vector, then you're dividing by area, which is a scalar. What you get is a vector. There is momentum. Momentum, you get momentum by multiplying the mass times the velocity. The mass is a scalar. Mass does not have direction, but you are multiplying the mass with something called velocity, which is a vector. So when you divide here, pressure is equal to force divided by area. Force is a vector. You are dividing by a scalar. When you divide a vector by a scalar, you get a vector. When you multiply a vector by a scalar, you get a vector. So in the case of momentum, you multiply the mass, which is a scalar, times the velocity, which is a vector, so you end up getting a vector. Okay? Yes? Is there a question? Or people need to be admitted? There's a question? Okay. Torque. Torque is the turning effect of a force. Sometimes when you apply a force, that force is going to make things turn. Okay? So you applying a force and that force causing something to turn, that is what is referred to as torque. The force can cause something to turn clockwise or anti-clockwise. So when things turn, they either turn clockwise or anti-clockwise. So there is direction there. So torque is an example of a vector. Others are electric field and magnetic field. So electric field is basically the force of attraction from a charged particle, and magnetic field refers to the force of attraction due to something which is magnetic, a magnet. Okay, so these are examples of scalars. With examples of scalars and vectors here. Do we have any questions before we move on to what it is we are actually interested in, which is carrying out vector addition? Are there any questions?
Sir?
Yes?
Torque again. The definition of, I don't know if it's stick or torque.
The definition of what? Can you repeat the question?
Of torque. The definition of torque.
Torque. The turning effect of a force. That's what torque is. When you apply a force, for example, I don't know, those on a merry-go-round, when you go to the park, there's that thing where you put your sisters and your brothers, then you push, then it goes around. Okay? So that pushing you're doing is causing something to go around in a circle, to turn. Or when you're trying to untie some spanners or nuts from the tires of a car, okay, you apply a force, and that force causes the nuts to turn, the bolts or whatever it is to turn. Okay, that is what is referred to as torque. Are we clear?
Yes, sir.
Okay. Is there another question? Ati?
Repeat the answer for the previous question.
I just said that torque is the turning effect of a force. A force can cause an object to turn. So that turning which happens either clockwise or anti-clockwise, that is what torque is. We'll learn about this as we proceed. I was just giving examples of some physical quantities which are vectors and those ones which are scalars. our main concern is on vectors. How do you add vectors? Okay. That's our main concern. How do you add vectors? We are only concerned with vector addition because subtraction of vectors is a form of vector addition. Are we clear? So our concern really is just vector addition, because vector subtraction is a form of vector addition, as we are going to see. So when you are dealing with vectors, then you want to add or subtract them. It is very important that you take the direction into account. When you're dealing with vectors, it's very, very important that you take direction into account. You cannot treat a vector the same way you treat a scalar unless you have done something to it, okay? So that's the first thing. When you're adding or subtracting vectors, direction is important. The next thing to note is a bit of terminology thing. When you add, after you add or subtract vectors, what you get after the addition or the subtraction of vectors, maybe you're adding 2 vectors, you're adding 3 vectors, the result is what is referred to as the resultant. This is very important because most of your time you'll be looking for this resultant thing, especially when it comes to Newton's laws of motion, Newton's second law of motion. Newton's second law of motion talks about a resultant force, which is a force you get after you add a bunch of forces acting on an object. Okay, so that resultant force is actually what Newton's second law of motion talks about. So we need to learn how to add vectors so that we can are in a position to actually work out what this resultant is. Okay. The other thing is subtraction. We do not concern ourselves too much about vector subtraction because, as you are going to see, vector subtraction is basically a form of vector addition. If a vector is pointing in this direction, like this one from A to B, then the arrow is pointing in that particular direction. Okay? If you change this arrow so that it points towards A, then what you have is a negative vector, the negative of this. So you put a negative sign. That's what basically minus is. Subtraction is in vectors. It is a vector which is pointing in the opposite direction to the vector you have been given. So if you've been given a vector which is pointing in a particular direction, then you can come up with another vector which is equal in size but points opposite the direction in which that particular vector you have is pointing in. That vector is going to be a negative vector, so it's going to be a minus whatever it is. It's going to be minus vector. So vector subtraction basically is a form of vector addition, as we're going to see. So when you're dealing with vectors, you might have vectors which are pointing in the same direction. Okay? You might have vectors pointing in the same direction. When vectors are pointing in the same direction, we say that those vectors are acting in the same line. Okay? When vectors are pointing in the same direction, we say that those vectors are acting in the same line. Vectors pointing in the same direction do not necessarily have to be in the same, they have to be parallel. Okay? If things are parallel, if vectors are parallel, it means that they are pointing in the same direction. Are we clear? Are we clear on this idea of acting in the same line?
Yes, sir.
If you have a bunch of vectors, you have got 2 vectors, you have got 3 vectors, then the direction of these vectors is parallel. Okay? these vectors you have, they are parallel to each other. It means that they are pointing in the same direction. Okay? It also, same direction also means that you might have a vector which is parallel but pointing in the opposite direction. Okay? That one also qualifies as a vector which is acting or pointing in the same direction. For the vector which is pointing in the opposite direction, such vectors, we put a negative sign in front of the size. In front of the size of the vector, we put a negative sign. So why are we interested in these? Well, it turns out that if your vectors are pointing in the same direction, you just add their sizes because the direction is going to remain the same. That's the first thing, which is very, very important. If you have vectors pointing in the same direction, you just add their sizes. You carry out addition like this. 25 meters plus 50 meters. You just add their sizes. Okay? Then you get the size, 75 meters. But the direction stays the same. The direction does not change. That is one thing going for when your vectors are acting in the same line or they are pointing in the same direction. When your vectors are parallel, when you add these parallel vectors, you just add their sizes. You add their sizes, then the direction remains unchanged. So the resultant of adding two vectors acting along the same line is the sum of the magnitudes of the two vectors. The direction of the resultant remains unchanged. So that's what you're saying. It can be two vectors because you can add two vectors, you can add three vectors, you can add four vectors. It depends on what you have. But as long as these vectors are parallel to each other, you just add their sizes. Then the direction remains the same. Okay? The other thing I want to point out is when you're adding vectors, you're adding the same physical quantity. Okay? It's not like you're adding time plus distance. No, that's not how it happens. If you're adding displacements, you're adding displacements. Okay? If you're adding velocities, you're adding velocities, 2 velocities or 3 velocities. It's not that you're adding velocity plus time. No, that's not what you're talking about. Are we clear? We're doing addition. You add the same physical quantity. You subtract the same physical quantity. You can't subtract time from mass or from length. Those are two different physical quantities. Are we clear?
Yes.
Yes, sir.
If one of the vectors along the same line is acting in the opposite direction, okay? So if one of the vectors along the same line, so you have got vectors parallel pointing in a particular direction, then one of those vectors is pointing in the opposite direction, okay? Then its magnitude is given a negative sign. So such a vector, the size of the vector which is pointing in the opposite direction to the other vectors is given a negative sign. So it has got a negative size. The negative shows that the vector is pointing in the opposite direction. Are we clear?
Yes, sir.
This is very important because we are going to use this a lot. Because after this, the trick we are going to do is we will try to make our vectors point in the same line or in the same directions. We are going to choose directions in which we are going to make these vectors point. Specifically, I can disclose along the x direction and along the y direction. So all the vectors we have, we'll try to make them point along the x direction, we try to make them point along the y direction. So you're going to have a bunch of vectors pointing along the x direction, pointing along the y direction. Then since these directions are the same, they are all the vectors pointing along the x direction act along the same line, we can just add them. Okay? All the vectors pointing along the y direction, they're acting along the same line, we can just add them. That's why this thing is very important. Adding vectors along the same line. If your vectors are acting along the same line, you can just add their sizes. If one of the vectors is pointing in the opposite direction, then the size of that vector is given a negative sign. Are we clear on what it is we mean by adding vectors along the same line?
Yes, sir.
Okay.
Yeah.
Next
No, sir.
comes to adding vectors acting along different lines. So it's not always possible for you to have vectors which are pointing, which are parallel, so that you can be playing only with vectors which are parallel. What you're going to find in reality are that we're going to give you a bunch of vectors which point in different directions. As a matter of fact, we will not give you vectors which point in the same direction, because that's easy to do. So what we're going to give you are vectors which actually point in different directions. So here is an example of vectors pointing in the same line. Okay, you have a box. There is a force of 10 newtons. This force of 10 newtons is exerted in this direction. There is another force of 10 newtons being exerted in the opposite direction. So this one, if we choose this direction to be the positive direction and this one to be the negative direction, so this one is going to be plus 10 newtons added with minus 10 newtons. That's why the result here is 0. You don't have anything. Are we clear? When you're dealing with vectors, you need to choose which direction is going to be positive. That's another thing you need to do yourself. You need to choose directions. Which direction is going to be the x direction, which direction is going to be the y direction, which one is going to be the positive x direction, which one is going to be the negative y direction, like that. So if we choose this to be our positive x direction, this to be our negative x direction, 10 newtons plus minus 10 newtons, you get a 0. That's why there is no force on this one here. Here you've got 10 newtons, you've got 10 newtons. These forces, as you can see, they are parallel to each other, so they are acting along the same line. Okay? If your forces are a vector as acting in the same line, then you just add their sizes here. 10 plus 10, that's how you end up with these 20 newtons here. That's the advantage of having vectors acting along the same line. Here you've got this box, there's a 10 newtons force here, there's an 8 newtons force here, they're acting opposite each other. If I choose this side where there's a greater force to be the positive force, to be the positive direction, so this force is going to be plus 10 newtons, which will make the opposite one minus 8 newtons. So 10 newtons plus 10 newtons plus minus 8 newtons, I end up with plus 2 newtons. So the result is going to be plus 2. So this 2 newton is what is referred to as the resultant force. This 20 newton here, this is a resultant. Here the resultant is 0. It's 0. Are we clear? This is the result of what you get when you add vectors. As you can see, here we are adding vectors 10 newtons plus 10 newtons. They are pointing in the same direction. But the moment vectors don't point in the same direction, like in this case, they are opposite, in this case they're opposite, that means you have to do vector subtraction. You have to choose which vector is going to be positive, then you have to choose which direction is going to be negative, then the vector pointing in the positive direction, they're given a positive sign, those vectors pointing in the negative direction, they're given a negative sign, then you add them, plus 10 newtons plus minus 8 newtons, that's just 10 minus 8 newtons, and you get yourself 2 newtons. This 2 newton is the resultant. We need to find the resultant. So you will have objects being acted upon by different forces. If you've got a bunch of forces acting on an object, then what we want you to do is to find the resultant. Are we clear?
That one.
Yes, sir.
Okay. Here is an example of forces, vectors, which do not point in the same direction. These vectors are pointing in different directions. Now what you have here is something called a triangle of vectors. You have vector A here pointing this direction. You have got vector B pointing that direction. So if I move along vector A, so it ends there, then I move along vector B, I find myself there. So I've moved like this up to there. That is the same thing as moving this way along the red line. This red line with the two arrows, this is what is referred to as the resultant. So this is how A plus B looks like. When you're adding vectors A and B, you move along vector A in this particular direction, then you move along vector B that particular direction, so you find yourself there. That is what A plus B looks like. Are we clear with that triangle?
Can that be referred to as the displacement?
It can be anything. It can be displacement, it can be velocity, it can be any vector. That's why we're saying vectors here. It can be anything. It doesn't matter whether it's displacement, as long as it's a vector, we can use a triangle like that. The thing with these triangles of vectors is they have to be drawn to scale, and also the angles have to be accurate. The directions, you have to be really, really accurate. So there's that problem. Most of us, what if the vector is a displacement of 100 and the B is a displacement of 300? Where do you find this? How drawing these things according to scale is a bit tedious. So using a picture, we can show you what A plus B is going to look like. Say it's going to be this particular direction, but we don't use this method to actually find A plus B. We use it for demonstrating what A plus B looks like when you're adding vectors. Okay? You move along vector A, then you move along vector B. The other thing you're supposed to be aware of vectors is a vector has got size, a vector has got direction. If the size remains unchanged, the direction also remains unchanged. It means that you can shift the vector as long as the size stays the same and the direction stays the same. And that is what we do here. This is what happens in this diagram here. I start from here, this end. I move in this direction. So I am moving in a direction which is opposite A. Okay? I am moving in a direction opposite the arrow of A here. So A is pointing this direction, but I move in an opposite direction to A. So that gives me minus A. So what I've actually moved there is something called minus A, because the vector I'm following is opposite the direction of A. Then after moving in the direction of minus A, I move along the direction of B, the size of B, the direction of B. So basically, I move minus A, then I move B. That is the same as moving along that red line. So minus A, I move minus A plus B, that's what gives you B minus A. You write that as B minus A. So this B minus A looks like that. Are we clear?
Yes, sir.
Yes. Remember, with vectors, direction is very, very important. You have to consider the direction. So if I move in this direction, opposite A, that's minus A, then I move in the same direction as B, I move in the same direction as B and the same size. So that gives me B. So basically what I did is I shifted this. I get this B, I plant it here. As long as the size, the length of B is the same and it's pointing in the same direction, then that's B. You can move vectors around as long as the size and the direction remains unchanged, then it is the same vector. Are we clear?
So does that mean A minus B is equal to?
Huh?
Does that mean B minus A is equal to A minus B?
Does that mean what? A plus B or A minus B?
Does that mean B minus A is equal to A minus B?
B minus A. So this is B minus A. B minus A. The direction is in that direction. You can see the arrows here. The red arrows. You have seen the direction? So that's B minus A.
So we follow the red arrow.
Yes, you follow the red
follow the
arrows
red arrows.
because a vector has got size and direction. So the red arrows are showing you the direction of B minus A.
Oh,
Yes.
Thank you, sir.
Yes. So in the case of A minus B, I start with B. I start from this end. So I move along minus B. So B is pointing in this direction. So I move in the opposite direction to B. Then at that particular end, I move along A. So that gives me minus B plus A. That gives me A minus B. Which
It
is,
would have been better if you post these things on YouTube. Some of us have been left behind.
yeah, it's being recorded. The thing is being recorded. So yeah, definitely it's going to be posted. Okay. So in the case of A minus B, so you move from here, then you move in the opposite direction to B, like that. So if you're moving in the opposite direction to vector B, then what you have is a vector called minus B. So minus B plus A. You move along A here. So at the end of the day, minus B plus A is A minus B, which is this one. So you can see, yes?
But how come you've said that the A plus B, we are getting that
I said what?
at the, for the A plus B?
What about A plus B? A plus B, you start from this point. You start from this red point.
Yes.
You move along A, so that is A. Then you move along B, that is B. So A plus B. The result of this A plus B is this one. This red line.
Okay.
Yes. That's
Alright,
it.
what about for the other one, like for B minus A?
B minus A. So you can see the A is negative, right? So you start from this point, you move in the direction opposite A. So if you're moving in the direction opposite A, what you have is minus A. So it's minus A, you're moving in the opposite direction like this, then plus B. You move like that. So you end up with minus A plus B, which is equals to B minus A. So it is this vector along that direction. These things, these vectors, you can shift them. So for example, this B here, in A plus B, the B, I have put the B here, right? The B is here. But in B minus A, the B is this side. I shifted it. I took it, I planted it here. As long as the direction and the size stays the same, then we are still talking about the same B. Are we clear? Because a vector has got size and has got direction. So as long as the size and the direction is the same, then it is still B. You can shift vectors around. Are we clear? Okay, so that is your
Sir,
B minus A. Yes?
on B minus A, the same one, which one is the origin?
Which one is the origin?
Is it B or it's A, it's negative A?
No. When you're talking about vectors, a vector has got a start and an end. That's all. Where does it start?
Yes, sir.
Where does it end?
Yes. That's my question, sir.
Here where there's a red dot here. The vector here where there's a red dot. That's where the vector is starting from. You start from the red dot, you move like that, then you move like that. That is A plus B. This is A plus B. In the case of B minus A, you're starting from this point, this red dot, then you move in this direction, the opposite direction to A. That gives you minus A. Then you move in that direction, that gives you B. So minus A plus B, that is B minus A. That's the same as moving from this point to that point. That's why you have A minus B there. Then here you're starting from this point, the red dot. So you're moving minus B in this particular direction, then you move plus A. So minus B plus A. That gives you A minus B. So you move like this. There. As the arrows are showing. Yes?
Okay, sir.
Yes, what's the question?
I wanted to find out where you're posting the video. You said you're recording.
Yes.
I wanted to find out where you're going to post it.
We post the link on Moodle, but the actual video is going to be on YouTube. So you got your Moodle, then from your Moodle, you click on the link for this particular video. When we upload it, you click on the link, then that link is going to take you to a video on YouTube.
Oh.
Yes.
Okay.
The other alternative is you can look for my channel on YouTube, then you can make a subscription so that you are, when I put a video which contains this course, then you can, you can watch it. But the official thing is I'll upload the video on YouTube, then I'll put a link in Moodle. So you go on Moodle, you click on Moodle on the video, then the link in Moodle is going to take you, it's going to take you to the video on YouTube.
Okay, so
Yes?
so why don't we use Pythagoras theorem, for example, to answer these triangular vectors?
Pythagoras only works when the angles are 90 degrees. But the other thing also, there's the Pythagoras where the angle is 90 degrees, but you also have other forms of Pythagoras where the angles are not 90 degrees. Now the thing with the Pythagoras stuff, you can use that, it might give you the size, but you also have to work out the directions. So you have to be very precise about the directions. All the directions, you have to accurately do that. And only a few of you probably have got such skills from your technical drawing or geometric and mechanical GMD stuff, that stuff. So not everybody can do whatever it is you're trying to suggest. Okay? So we need to find, we need to find a way of doing this which works for everybody. Even if you did the thing you're suggesting, it might take you a bit of time. And in an exam, you don't have such time, because an exam is 3 hours and you can't just answer one question. You have to answer a lot of questions. Are we clear?
So put directions, we'll put north, south, east, and west, or
No, actually, this thing here is showing you in a picture way, okay? This triangle of vectors is there to show you in a picture how A plus B, B minus A, or how you'd work out stuff like that. But practically, this is not how we work out things. There's another method which we use to do that, and that's what you're going to look at tomorrow. Something called components of a vector. Using components. So there's a method where you use components of a vector. So you're going to see what a component is when you meet tomorrow, and how we use this method of components to actually find out where a vector is actually going to point. Do we have any other questions?
Okay.
Yeah.
No other questions, sir.
All right. If there are any other questions, now that it looks clear on what we are trying to do, what task we have at hand, are there any other questions?
I would like to ask one question.
Yes.
Does that qualify the statement that B minus A is equal to A minus B?
No, it's not. It's not. The size might be the same. The size of B minus A and A minus B might be the same size, yes. But the direction is different, as you can see. B minus A is pointing in a different direction and A minus B is pointing in a different direction. So the direction in this case makes it not to be equal or not to be the same. The direction is important when you're dealing with vectors.
But the magnitude.
Are we clear?
Yes.
No.
Yes.
Yes, sir.
Yes.
I have a question.
Yes.
On the other triangle, I don't know whether it's triangle, but you think that the direction matters. Now, if A minus B, is it A minus B is equal to negative B plus A?
Davison and Tumbo, one of you should switch off the microphone. Tumbo, switch off the microphone.
Sir?
Someone needs to switch off the microphone.
No, my Gmail account is connected to my YouTube channel. That's why.
What? Davison and Tumbo, one of you needs to switch off. Okay. So yeah, speak. What's the question? If you're not speaking, switch off your microphone. Alright, guys, we're done. You're going to watch the video. We'll continue tomorrow if you have any questions.
Mr. Scalars.
Yes.